and eventually also look at advanced use case when we are talking about higher automation, and see what are the challenges. We mentioned some aspect of functional safety and SOTIF, but also aspects of security. We can have a discussion. The goal is to be as open as possible. We don't have slides, hundreds of slides. We just want at different steps in the discussion or in the presentations to stop, to discuss, to try to, from your point of view, see what are your challenges in terms of including V2X in ADAS. And we are lucky that we have around the room some people on cyber security, but also some people active in sensors activity. That are building sensors. And so we need from a V2X point of view, we don't have the solution, but you may have some advices how to use vehicular connectivity in advanced driver assistance systems and in automated driving systems. So it's an exchange. We are a relatively small group, so don't hesitate to just intervene. And so just about me, my name is Maxime Flament. I'm the Chief Technology Officer from 5GA. I mostly look at the work program made of different projects within 5GA, and I try to coordinate the different topics that are important for the association. We have 7 working groups, and these 7 working groups endorse the work that is done in the projects, which we call work items. The main outcomes of 5GA are generally technical reports, if you go on the website, but also sometimes proof of concept, prototypes, also demonstrations, position papers, etc. So very, very diverse outreach from the association. And if we look at what is our purpose, it's all about connecting people, vehicles, and transport infrastructure at the global level. We represent automotive and telecommunication industries. We are about 130 members, and these 130 members get together to try to understand each other from both industry and automotive. At the global level, see what kind of solutions can be brought to the market as soon as possible. We often try to look at smarter, safer, and more environmentally sustainable services, but these are not the only services. Of course, that connectivity is being used for many, many different purposes. And so we can also talk about other services beyond just the smart and safer kind of use cases. Over the last few years, we have issued a few roadmaps. The first roadmap that we came up with was a technology roadmap that was in 2018, related to the deployment of LTE V2X. So that means it's a standard that was produced by 3GPP in 2017. And in 2018, we said, okay, when will the market be able to adopt this technology roadmap? We saw, especially in China, a huge deployment of this technology, and the adoption was quite wide, encompassing quite a lot of vehicle manufacturers. We had, I think, 14, 15 vehicle manufacturers adopting the technology. Now, the technology was not then it is still being considered in other markets. We are looking at US next market, but also looking at Korea to adopt LTE V2X short-range communication. But in general, then we said we need a little bit beyond just a technology roadmap. What we wanted is to make sure that we had an idea of what kind of use case were coming up at what point in on the market. And for this, we came up with a use case roadmap. This is a simplified view of the use case roadmap. And you can see that it bundles both the connectivity and automation. It starts on the bottom left with more. Can we make it a little bit bigger on that one, or is it bigger? Is it possible to enlarge?
I'm not sure actually.
No, but doesn't. So I hope you can all see. So on the bottom left, you can see basic safety use cases, intersection safety, vulnerable road user protection, especially on collective awareness, local hazard warnings. All these use cases on the bottom left are more dedicated to interact with the driver and influence the driver behavior. Now, if you go on the right, on top of that roadmap, you see use cases that are gradually more automated. We can start with the automated valet parking, then going gradually towards teleoperated driving, but then even more than where it creates a need for a cooperative intervention is all aspects of cooperative maneuver, cooperative adaptive cruise control, etc., where then the connectivity between the cars become very, very important. Now, at VGA, we are always looking at connectivity, both from connectivity to the mobile network, with all the challenges that it entails, and also the connectivity between cars, so in a peer-to-peer fashion, and also to the infrastructure. And I'm going to give two examples of connectivity and use cases that are more on the bottom left part, so the most basic ones. And then after that, we will look at On, who's from AutoTalks, who's going to talk about a V2V interaction, but more than looking at cooperative automated emergency braking. And then Andreas from Bosch will then show another one, which is then not on V2V part, but then looking also at the possibility to use the mobile network for orchestrating movement assistance inside an intersection. So very simple ones. Perhaps you know all these. This can be done either via a kind of peer-to-peer V2V connection or via a backend. A vehicle, back in the number one there, detects that there is, for example, a slippery road. It transmits the information in a standardized type. It then sends this information either to the vehicle behind directly or into a backend. That backend can do some data aggregation, also some processing, and then eventually bring this information to the right vehicles that are coming to the affected area. It complements the sensor range, and so really, in a nice fashion, improves safety so that the driver can act upon the warnings. Now, another kind of very simple use case that is on the roadmap is all aspects that are integrating the information coming from the intersection. So, but that requires, of course, information or intersections being equipped somehow, or the traffic manager knowing exactly what kind of signal phase is coming at the intersection. So it enables, of course, traffic light information on the dashboard. It also enables more elaborated use cases, such as red light violation information. So when a vehicle is about to run a red light, then all other vehicles can be informed about this potential violation. And then also when it comes to fleets that are given some priorities, for example, the buses, the public transport, and also the emergency vehicles, the traffic light preemption is something that is very interesting for when it comes to interacting with the intersection. So these are two examples, and these two examples can be done both with peer-to-peer communication, but also with activity or interaction with the interface, an API somewhere that is bringing the information from the internet. Now, where we are challenged at the moment is when it comes to increased automation. So, to what extent can we start trusting the information that is being received so that we don't only inform the driver, but also bring this into the vehicle system, and that the vehicle system starts to act upon it. So it can be here in that case, in the case that we have here, a red light, a light that turns red without any intervention of the driver. The vehicle that is perhaps in L3 may not detect be able to detect accurately the red light, but then acts upon the information that is being received from the intersection controller. So when automation kicks in the V2X, or when V2X kicks in into ADAS, there are challenges that we have to talk about, and that's where we wanted to perhaps interact today. And the first example that we wanted to bring is the V2V assisted automated emergency braking. Everyone knows it a little bit, but I want to just introduce here Onahan from AutoTalks, who is going to just give a few slides to illustrate it.
Yeah, thank you. So before I start, just want to add about the examples. As you know, the automotive market is heavily regulated, and no OEM is adding anything unless it's forced to add it. So in the example before of local hazards, it's already in the Euro NCAP 2023 grading. So local hazard gets 10 points. And in 2026, it's still under discussion. It's still going to be 10 points or more, but it's the triggering conditions are going to be more defined, and how it exactly is going to be done. And so it's not that only us see value, it's only also the safety regulators, Euro NCAP see it. And if you look at my example, just want to show a video.
Actually, turn on the video. So, video.
So if you talk about
shall I turn on?
So if you talk about regulation, what we show here is a testing. I mean, it's not a real testing, because in the testing, this is going to lead to a crash, but this is an emulation of a test of actual test protocol that is currently part of the China NCAP. Okay, I forgot to define NCAP. NCAP is the new car assessment program, which defines the safety stars of the vehicle. And from 2024, in China, there are 2 tests that are requiring V2X, and this is one of those which we recreated, and it shows what will happen if there's no V2X. So what we see, what we see is that this actually impacts the car makers in Europe, in China, and we see that all foreign OEMs in China are adding V2X just past this to get the 5 stars, because it's very difficult to get 5 stars. You always lose points on something, and if you have V2X, you can actually get like simple points on this. Chinese OEM are still behind because now there's very aggressive price war in China, but that's a different topic. So it shows, if you look at this scenario, why the need for automatic braking is sooner than later. Still, the market is not there. So what I would like to show you is the evolution that is needed to achieve that. So where we are now, this is day one V2X. In day one V2X, what we see on the left side, we have V2X, which can be standalone or part of the cellular network, or 5G connected to the NAND, to the cellular modem. And usually, the information goes from V2X to the head unit, meaning it digests information and provides warning. Because, for example, to provide local hazards, the ADAS doesn't need to do anything with that, because it's even not something that the ADAS processes. It's not information which is common to ADAS. And there is a GNSS to provide information that this is a key element of any V2X network. But once we move to day two, there are several changes. First, everything should be ASIL. And I think we'll discuss this later. ASIL means functional safety. ASIL-B, it means that you can trust the system that it functions correctly. So the GNSS, the positioning must be ASIL, the V2X must be ASIL, and then there's also an aspect of security, which comes a bit from the software-defined vehicle, because if you look at software-defined vehicle, it means that usually the TCU is like a smartphone, and you can add a lot of code on top of it, so it's very hard, as we see it, to isolate the generic smartphone app-like application from the safety-related code. I mean, maybe it's possible with a complex hypervisor, but today there should be some kind of isolation once you really go into hard braking. And the difference is that now the V2X doesn't make the decision by itself. It sends objects to the ADAS, and then the ADAS consider V2X like any other sensor. So it doesn't matter if it's camera, radar, or LiDAR, V2X is another sensor. In theory, because there are some challenges. So before I go to the challenges, so let's even say what happens if V2X is not in the ADAS. Still, we argue that it can provide a lot of value, even if it doesn't directly impact the braking decision. For example, every vehicle has some pre-braking functions, which takes like 200, 300 milliseconds, like adjusting the pressure in the brake pumps, or pre-tension the seatbelt. So that takes, or even adjusting the thresholds of the other sensors, because if you have a camera, every other sensor takes a lot of time until the sensor detects reliably the road users. But if you tell the sensor, you know there should be someone over there, then you can adjust the threshold and decide faster. So that alone can give 200, 300 milliseconds, but it's still a lot. So even if you have no automatic braking, it's still valuable. Here we see an example that we did in a demo with 5G in Malaga, Spain. That was, I think, a year ago. And we showed a bicycle crossing a street. So see here that just the wheel of the bicycle. So at this phase, no other sensor could have detected the bicycle. No camera, no radar. It's not possible to reach a reliable decision at this phase. But in V2X, the alert was ready long time ago. So this is why for vulnerable road users, two-wheelers, it's as important as for vehicles. And I forgot to mention that the vision of V2X is not only for vehicles. The vision of V2X is for all road users, because you cannot get to vision zero accidents only by eliminating the accidents of vehicles. You need to eliminate all accidents. So in this example, we showed the two-wheelers. Now, why do you really need the automatic braking? So there are two reasons. The first one is that today drivers get too many warnings. If you buy a Chinese car, most probably you will be very annoyed by the warning. And your NCAP is aware of that, and they don't like the situation. They don't like to see that the easiest way to pass and get the points is by annoying the driver. So it's kind of an anomaly, because you get a safer car, but the people actually turn off the safety equipment. So it's not really safer. So the only way to get real safety is to actually brake the car and stop those unnecessary warning. And the other aspect here is the reaction time. Because if now you have a forward collision warning, the camera detects an object slowing down ahead of you, you get the warning, you know what to do, because you see the object in front of you. In V2X, it's completely different because you don't know what's happening. You get an alert and you don't see anything. You don't know if what's happening. Is it a bike? Is it a car? What's coming from that? It takes you time to digest. And that time is very precious. So here, the driver is struggling more to react. So that's the value for automatic braking. But here's the challenge, because as opposed to all other sensors, there's no way to corroborate V2X. If you look at if there's a camera, then potentially there's a radar that can corroborate it, a LiDAR, or if there's camera, maybe there are two cameras. You will not make hard braking decision based on a single sensor. But on V2X, it's completely different because that's the superpower of V2X. It's the only sensor that can detect across the corner. So how can you trust it if you cannot validate it? I mean, the simplest way to say it is that let's wait until another sensor validates it. But that's defeat the purpose, because then what do you gain from V2X if you wait? So what we propose is to do like a two-step approach. First one is once you get the initial alert, you start with comfort braking. Comfort braking is requiring ASIL-B. So ASIL defined the risk that can be caused by a false decision or missing a good decision. And by a false decision, if you are now making very hard braking, you can actually risk all the cars behind you. So if we limit the safety grade, the ASIL of V2X to ASIL-B, we can define a deceleration which is still acceptable, can still prevent some of the accidents, but limits the potential risk of a false braking. And the hard braking is kicked in as an ASIL-D only when there's another sensor. So what will happen, for example, if you look at an intersection, once, for example, a bicycle is coming, the car is continuing, the bicycle is continuing, the car will start to brake, but not too hard, something like 0.3, 0.4 G, depends on the situation, on the calculation. And then once the bicycle will be seen, then you can get hard braking, which is like the maximal force of braking. But another element that can increase the validity of V2X is doing map matching. And here you can see an example that there is a car approaching the roundabout in the top right corner. So if you just look at the trajectories of vehicles, so the vehicle on the right supposedly will collide with the other car and it should be warned. But in reality, it will not, because it's now taking a right exit lane. So the map matching doesn't only tell where the car is now, but where is it heading. So if you know that the car is now heading right and doesn't even going to meet the self-vehicle, then alert will not be raised. And on the other end, we see now a car inside the roundabout. And again, if you look at the trajectory, it might show that there's no risk. But in reality, there's a big risk because the car in the roundabout continues to turn and then impose a risk on the car which is now entering the roundabout. So this is a key criteria in order to do any action based on V2X, to use a map matching and preferably even lane map matching to know the future direction.
So what is written here on the top, because it can be trusted after
lane matching.
Lane matching.
Can I ask a question?
Yes, of course.
How the quality of the tires or the difference in pressure of tires affect the braking distance, basically? Because I mean, this is so relevant. The braking.
I don't know how to tell you what to tell you about this. I think it's similar to all other sensors because it doesn't matter if you now have a camera and the camera tells the vehicle to brake. Or, I mean, it should be identical. This is like a common ADAS problem, so I don't know how to quantify this.
They also ask some questions. So
if I understood correctly, you are relying or you are emphasizing the importance of the GNSS positioning as an input data for the decision making at the end.
Mm-hmm.
So one of the main challenges is that data in real time in different places on location would be inaccurate and sometimes lead for a misunderstanding. Even when you try to fuse it with other trajectory, you could get a false alarm for driving in the next lane or whatever. So how do you recommend of dealing with the challenge of that inaccurate data as an input?
So first, you're correct. The GNSS accuracy is a key issue in V2X. But what we see in the last years is continuous progress. We started with the L1 GNSS, and now everybody's applying L1 and L5, and L5 adds a lot of accuracy. I mean, in the L1 days only, it was very difficult to reach even road level accuracy. But with L1 and 5, you can, at most cases, if it's not deep urban, you can easily get lane level positioning. And today there's also visual automotive, so you can use the visual cues like Mobileye started to use this visual map. And the sensor getting and people are applying AI at positioning. So positioning, it might look like a steady market, but it's really making a lot of progress. So it's needed for autonomous vehicles. So we see it also in regular vehicles.
So maybe what you mentioned from day 2, when V2X connected to ADAS, it's part of the crucial side. So you receive different sensors like GNSS, where you have very accurate position, and this way V2X can decide much better, and not as standalone solution where it's actually doesn't know where it's located.
Even today, when we say GNSS, it's not necessarily the GNSS directly. It could be a positioning subsystem in the vehicle, which fuses information from the camera and from L1.5. Correct. I mean, it's not only GNSS. Only in aftermarket device, you don't have anything else, but in a vehicle, you can get very accurate.
An additional point that was mentioned by...
And another thing is also, you can also, you have also a camera, and the camera tells you on which lane you are. So you have additional information, because the camera can tell you you're on the rightmost lane, or the middle lane, or the left lane.
Yeah, right. I totally agree with that one. It's just that you really put an emphasis on the real-time decision making. And
It's real-time, yes.
Really
but you know in real-time.
And there is some more computational, even a millisecond for a geo-registration for self-geo-positioning could be crucial for the decision making.
Oh, but you always have, the positioning is always in real-time. You always have the most accurate position in the vehicle always. This is like granted.
An additional point.
Another question there.
Yeah, for the question, maybe for reflects to also to the calculation, you mentioned in the first example, the backend decision. So it's some points at one who you trust, who runs this backend, and who pays for this backend. Yes, somebody need to manage to build this backend decision from different vendors that share information to this general cloud in each place and provides this data. So I don't know in practical level when it's possible at all.
And that brings us very well to the next presentation, because what On showed is really a V2V peer-to-peer exchange of information. And in theory, then if you're talking day 2, you're talking about some kind of ASIL certification, and then so the path to trust is a bit simpler. And, perhaps that's a good segue to just show the next use case.
But there's another question.
And then we can continue the discussion. But yeah, let's go.
I was just wondering, before the decision-making process, you indicated that there's a challenge for the drivers, that when they come into the intersection, this scenario, they don't see each other. And since the V2X comes into operation, wouldn't it, I don't know if it's a challenge to share with the vehicles this picture like top down, or like the ADAS shows you a lot of information, visual information. So this is kind of it gives you a notice. Be aware. You take this into consideration. And also this way the driver would be ready to the fact that the V2X is going to intervene with his driving to brake him or to, it's a kind of alert.
Yeah, so it goes down to the HMI question. And this is a very critical question to OEMs, and they spend a lot of time studying the right way to present data to the driver. And now if you talk about Euro NCAP is also going to say then if it's something that is bothering the drivers or not, because now Euro NCAP is dealing more in that. So it is a possibility, but OEMs are very careful when they alert drivers, because if they alert too early, they say people will not use the system, it will bother them. If they alert too late,
just share the picture.
If you talk with
the scenario,
the German OEMs, they are really strict about when alert can be made. But
yeah, I think the HMI is going to be key.
From imagery, from satellites or whatever.
No satellite. Where does the V2X gets this picture?
The bird eye.
A map only with
the V2X will provide the camera information that it gets. So you have a three-dimensional ADAS or navigation.
Was a very good start. Thank you, Ron, for this. And then I would like now to give the floor to Andreas Schaller from Bosch. And he's going to give us another use case that is considered at 5GA. But then the subtlety here is, and I'm just trying to focus on that one. Yes. The subtlety here is that now it's not about V2V communication, so the two vehicles don't have to be equipped with the same technology, but then now it's using the mobile network and it's relying on the mobile network capabilities to deliver a specific service, and in this case, the intersection movement assist. So, Andreas, I give you the floor. I hope we can hear you.
Yes, please let me know if you can hear me.
We can hear you very well.
Okay. So, thank you very much for your presentation. And just to start with the audience. So, what you heard from On was, as he mentioned, is China NCAP has this in 2024. This is something which is happening at the moment. OEMs are implementing it and are testing it based on the V2X, vehicle-to-vehicle communication On just presented at the moment. What you see now from my side is a little bit a different perspective. It's a little bit more into the future, and it's a public funded project which was done in Germany about AD level 4 vehicles. So now we are not talking about, as you can see in the video, vehicles which have a normal driver. Now we are talking about AD level 4 vehicles. That's very important. It's a different view now, but we wanted to have different views to start the discussions. So in this project, it's also about an urban intersection. It's about different AD level 4 vehicles in that city, on that street. It's about infrastructure in that city. And for example, as you can see in the partners, it's Bosch, Nokia, it's Daimler. Nokia provided the network components to have edge servers, and at these intersections having 5G local connectivity. And if we have different scenarios in this for VRUs, for mixed traffic, and you will see now one of these use cases, but in the project, there were about 5 to be done. Now, if you go to the next slide, we go a little bit more into the project itself. So the project is done, and this is on the left side, in an urban environment outside of Ulm. Ulm is a city between Stuttgart and Munich. So this intersection is prepared with some infrastructure, and the infrastructure was already used by many different public funded projects in Germany. So meanwhile, it's getting a little bit famous because you would not put the infrastructure in place for just one project. So what you can see is there is sensor infrastructure there used. There is in the middle 5G LTE connectivity used. There are fully autonomous vehicle used. There are connected vehicle used. there are connected public transportation or public vehicle use, like the small cleaning machine you can see. And in the project, we also use connected via use like pedestrians and bicycles. Now, the interesting story is that in here, it's all about that all these vehicles, all these pedestrians are connected via one system. And this is showed on the next slide. So on the next slide, what you can see is there are the vehicles, there is the infrastructure, and there is a combination between the sensors of the vehicle and the sensors of the infrastructure. There's a perception for AD level 4 vehicles and infrastructure separately. What's happening afterwards is that this environmental modeling, where are the vehicles, what's happening on the street are shared. So there is a common environmental model available on the edge server. Based on this edge server, a behavior planning is done. One behavior planning for all of these connected vehicles. So that means that in this project, they try to offload the behavior planning of this AD level 4 vehicles into one infrastructure. This behavior planning is then finalized for all vehicles and is sent to all vehicles. And then the motion planning itself is done again by each vehicle separately. That means the functional safety part, having a functional safe drive, is still done by the vehicle itself. Only the non-functional safe part, doing the overall planning of the intersection, is done by the infrastructure. So motion planning and control is still in the hand of the vehicle. So this is a little bit different now what we heard before. In this case, the functional safety stays completely inside of the vehicle. Now, this is the system in general. Now we see one video now describing how the system works on this intersection.
Let me show that.
Yes, now it's your task. Should be sound.
Let me just stop if I need to go.
No, just
the
let
use
it
case
run.
cooperative turning of the Lucas project involves 3 connected automated vehicles performing a cooperative maneuver in mixed traffic. The vehicles shown here shall cross an intersection of 3 merging roads. According to the existing priority rules, the blue vehicle has the right of way. The cooperative planner now initiates a cooperative maneuver that requests the blue vehicle to decelerate, enabling the other 2 vehicles to cross in parallel. In other words, the cooperative planner strives to improve the overall traffic efficiency and reduces fuel consumption by optimizing the order in which the automated vehicles pass the intersection. Let's take a closer look at what the maneuvers look like from the vehicle's point of view. While approaching the intersection, the automated vehicles log in onto the server automatically. Then they receive the server data, which provides a precise awareness model of their surrounding, even on objects outside of their own field of view. The cooperative planner initiates a cooperative maneuver that determines the passing sequence and the time slot for each of the vehicles to cross the intersection. These instructions are executed by the vehicle planner. In this example, the blue vehicle yields right of way to the other vehicles to improve the energy efficiency of the overall traffic situation.
Okay, thank you very much, Maxime. So maybe we go back one slide to this,
Yes.
just to give again a little bit of understanding what we have just seen. Okay, yeah. So what we have just seen is this corporate maneuver, and there was a discussion just before saying, why can you not give all this information to all these vehicles? So in that case, it's exactly from a research perspective, this is exactly what have been done. No? So you give all the AD level 4 vehicles the same kind of information. You do the planning for the intersection, and then the real maneuvering is done by each vehicle out separately. That was one example. I mean, there were of this project. There were other examples done with VRUs, bicycles, and other vehicles. But I think this one is the most prominent, and it fits a little bit into the discussion which we just had before. This is why I've chosen this scenario to show you today. And with that, I'm open for questions and for a lively discussion.
Any comments?
So hi, I'm Goran Barkan from RB Robotics. Also many years at General Motors, so well familiar with their challenges. So I've been preaching for what I call cooperative vehicle to infrastructure, not just sensing, but definitely smart mobility, because I don't think the vehicles will be able to handle this by themselves in the right safety level and the full ODD. It's simply not economical. Eventually, I've worked for 5 years with Cruise in San Francisco, so it's really a struggle. So I think that's a very good approach. I think everybody will tell you that the challenge is regulation and cross compatibility for all these communication, and who's responsible for the modeling. Is it joint? Is it, how does it combine? Who owns it? Who owns the data? Who's liable? So I think that's what I get also. Every player in this ecosystem needs to make his own money. So it's hard to build solutions that are so cross industry. I'm not saying I think that's the way to go, and I really like the model. But I think one interesting discussion will be on how do we think it is the right way to break this barrier.
So actually, I have one question that maybe relates to that.
Introduce yourself.
Yeah, Asaf Smon from Cybellum. Nothing to do with V2X, but personally interested. So when we're talking about day 2 scenarios, that kind of creates asymmetrical position from an economical perspective, because the cars with all the sensors would actually provide value to, let's say, standard V2X cars that don't have any sensors, any cameras, but they could still benefit. And some OEMs might argue, you know, why would I invest and provide value to the entire industry where everyone kind of gets the same benefits? So I guess the question is, are there any thoughts or efforts about a transactions level around that, where basically, you know, you could even consider blockchain or things like that, right? When basically, if I'm an OEM that have cars that don't have all the cameras and I want to benefit from those sensors, then maybe there's some, I don't know, transactions going around between those connections. I don't know if that's anything that anyone think or discuss.
Very, very good point. So I'm not entirely sure, but at this stage, within 5GA, we often consider that a car that would come with connectivity and even the V2V, short-range communication, a car that has connectivity would also come with some kind of sensors, at least not a full-fledged sensor for automated driving, but at least some ADAS sensors. But that's a very good point, because I didn't think of a car that had absolutely no sensors and then would benefit of other vehicles.
I mean, all the new cars have sensors. This is an assumption. You cannot get a new car today.
But even if it's not,
but you can say, for example,
it's not connected.
Yeah, no, but you can say, for example, if one car has more expensive sensors, for example, has more cameras or LiDAR, and other cars don't have LiDAR. But I think the benefit is a benefit for the society. If, for example, you have a better sensor and you detect the bicycle and the other doesn't detect the bicycle, still you protect the cyclist, and you don't want that this cyclist will be hurt even if the other driver has a lower cost car. It doesn't good for anyone. You know.
The question was about trying to break the business model, I understand, and then see whether there is a transaction based.
Obviously, there's a society benefit, but I'm just thinking like if there's any associated investment, right, that we have to consider just for that.
Maybe one.
Okay, yeah, sorry.
Yeah, Andreas wants to answer.
Maybe just one thing to add. So, I mean, as you can see, there are different OEMs. Vehicles from different OEMs were on that slide. No? You see an Audi, as in Daimler. No? And what we do here is an infrastructure, no? An infrastructure for traffic management. And this was an R&D project. But if we now look into China, for example, we see that their next systems, they call it a vehicle road infrastructure system. Vehicle road infrastructure system. And it's really about a platform to control traffic. And each vehicle has to be connected to this platform. So, and I mean, in 5GA, we got this China SAE paper last November, and I was really surprised that what this R&D project, what you've shown here, so parts of this is what they put on paper now. They more or less said that we would like that each vehicle is connected with this platform in the city, on the highway, national-wide. And we are going to test this in 10 cities in 2024. So the system, what you saw here, a combination of what On said and what I showed, is what currently discussed in China as a national platform.
And also in the US, there's a lot of discussion about smart intersection deployments. And those smart intersections are capable of detecting, having sensors, the camera, LiDAR, detecting all the road users in the intersection, and just share this information.
Vision comes from the infrastructure.
Yes.
Think of another.
And this is funded by the government, the US government.
Or by No Traffic, for example, from Israel.
Yeah, No Traffic is deploying, but they get money from the government.
Yeah, they're from the cities, not. Yeah,
yes, from some for cities, some for the states.
And they monetize on it, and that's maybe another business model. You can decide to build a pole with sensors and sell the information to the cars, even if you're not an OEM. Right? Or municipality or something, but they can monetize on it and say, I'm going to put smart intersection, just like No Traffic is starting to do, and then if you drive into my city, you can drive autonomously, unlike others.
But this is a service.
There are no discussions about it's more.
This is a service for the municipality that want the citizens to have a safer city, and they say, now I have a budget, I can buy an ambulance in this budget, or I can buy a smart intersection, and then I don't need the ambulance because they're going to build a
yes, I definitely get it from municipal, public sectors. It's very clear. I was just thinking, is there any kind of things being driven from the private sector with some monetization aspects to it?
So well, I can perhaps try to give you one possible answer. If you go in some parts of the Chinese pilots where they have this kind of smart intersection, so they have a completely comprehensive view of the movement in the intersection, and they offer that to this information to the approaching automated vehicles, such as a Baidu vehicle. It approaches, it signs up to the service, and then gets that extra service with extra confidence and extra quality of service. So it also gets information on synchronization, etc. There are additional services that are provided to automated vehicles, as opposed to normal vehicles that are driven where they get just signal phase information. So it may be monetized this way. So you provide an additional service, and they call it dual intelligence. So Andreas mentioned what the vehicle road infrastructure, and they call it dual intelligence. And what was surprising is that they can divide by 10 the computing power that is necessary to navigate the intersection at the vehicle side. So instead of 1,000 teraflops, they would need 100 teraflops only to be consumed in this area. So it's just an order of magnitude. Okay. Any other comments? Any other concerns about, the two? If you compare the two approaches, you don't see an elephant in the room or no somewhere?
Spoofing.
We're waiting for day 3, not for day 2.
Security may be a problem.
Spoofing.
Yes, spoofing. You could have any kind of attacks that could be put in there. But I think in general, this trust. I would call it trust. So how do you trust the vehicle that is coming from your right and then that is coming in? And how do you trust that information that is being generated and then being received? How do you trust a system that is at the edge and calculating some kind of trajectory and recommending some movement? That's the main challenge that we at 5GA at the global level we have on trying to understand, where do we shift from just a simple warning to the driver towards being trusted in an automated driving environment.
So what are you doing to
research
this trust issue?
Because these are ongoing discussions, and so it's all about functional safety of the intended functions, eventually also cybersecurity protection. And so I just want to give you an illustration on how we can increase trust, and we have basically 5 more minutes, but I will share the slides. But if we look at the environment of safety concept, it's relatively simple, but you have to take it step by step. You can increase the safety at the level of the transmitter. So on one side, so put additional safety at the transmitter, increase the safety at the receiver, but you can also start corroborating information from the sensors and the V2X information. So you just in a couple of messages that you receive, you just receive the information, and then you say, I start to trust this information, this car, because it's giving me the right information, because I also sense it from my sensor. Now, there is, of course, a loophole, because if it's detected by the sensor, it may not be very interesting to receive the information from the V2X point of view. So, and then number 4 here, I have wait for V2X corroboration from another vehicle. So number 4 is just that another vehicle is also giving me information that can be cross-correlated. And number 5 here is to look for other kind of message. So in general, we have messages coming from mostly cooperative awareness message, so just the position, the speed, and the direction of the ego vehicle. But if you start with your own sensor as your vehicle, you're giving information about another vehicle, so that you detect, or another pedestrian that you detect, and you're giving this information to another driver, then it starts to be, you can start to corroborate or correlate the information that you see and that the other vehicle are seeing into one, and then build up trust while these messages are being received. And these are discussions that we have almost daily at 5GA on, where is the best way to start trusting each other from a functional safety point of view and safety of intelligent functions. And so if you are building a system that is starting to use connectivity or messages from other vehicles, you will have, our recommendation is to start looking at this very early in the buildup of your system, because you cannot do this at the end. You just have to take these into consideration very early and not believe that everyone trusts each other and everyone will act upon your messages that are being sent. So yes, I just had a little animation, but it doesn't matter. Okay. So we published a study not so long ago on how to address this in an environment where we have non-ASIL component. So, and I'm going to be brief, but it's very important to be open to have in a system, in a functionally safe system, or being open to have channels that are uncontrolled or open. That means that you have to apply both. If you have the vehicle A on one side having a safety concept, and then the vehicle B on the other side having also a safety concept, in between, when you have a transmission, you consider that you have an open channel. You monitor this channel, and via this monitoring of the channel, you can still guarantee that the information that is being received is still ASIL compliant, even though there is a component in the data chain that is not completely controlled. And this brings us to mutual trust, the concept of mutual trust, which we are working on, and we are going to publish a paper in the next months, where this is all about, okay, what kind of information do I need to send from the Ego vehicle about my capabilities, so that the recipient can rely upon it and then bring it into its subsystems that are also ASIL compliant. And if there is any interest in your part to listen to this, of course we can establish more discussions, interactions, and then try to even help you to be compliant. But anyway, that was going a little bit too much into the details, but then it was trying to give the complexity of the current discussions.
Yeah, just want to add about security. Security is embedded in V2X. It's part of the messages. There's a very strong security layer which applies a public signature. And it's not only enough to say I'm secure, because it's not secure. You need to certify and prove that you're secure. So the hardware security model, the HSM that stores all the secure assets, must be certified. It's very strict certification. There's certification for Europe and for US and different one for China. And in addition, we need to pass all the UNECE 29. So it's really tons of security standards. We need to apply all the best industry practices. We can do only the best that we can do, but it's really a lot of work that is invested in that.
I think that doing it standalone, it's not enough. So what you mentioned, I think, is point 5 in previous slides, that you need to rely on other sensors as well. So for example, you have additional cameras that says it's a real vehicle, or real intersections that have V2X and not somebody just pulled something that transmits the data and everyone taking it. So what all mentions that you still need to meet WP29, UNECE, and everything is according to V2X, it's one point. But as ecosystem, with all subsystems working together, this is how you can build trust. Otherwise, you cannot rely only on V2X versus V2X. It's not enough from cybersecurity perspective, because we could violate a company and see how we can easily work on this V2X connectivity without any problem. It's standalone not enough. You need like ecosystem on one vehicle, connecting with ecosystem on other vehicles. This is how you can build trust. Otherwise, I don't think it will work as a standalone. Also the same for cloud solution, because the number of attack passes here is enormous. How we can go and penetrate the system, this cooperation between the vehicles. And the work doing it by step by step, and building this with a lot of subsystems, it's something that can help and improve it. And I believe that this is how you need to do it. On the vehicle level, vehicle will not drive. If you do it on vehicle itself, is more and more stuff. Okay, you have all this endless number of ECUs, vehicle not driving. You just don't have power to drive.
Yeah, but you can play great gaming.
Yeah, exactly.
You have the screen, you have the GPU power.
Yeah, but you
Just
can
stand and play.
you start stop not work.
Andreas, last words. We are almost we are at the end of the hour, but
Yeah, it was a little bit difficult to follow from here, but yeah, what I wanted to say is that this question of connectivity, trust, and on functional safety have different levels. I mean, there is trust in data, which is first of all important when we speak about ITS services. Now we have trust in functions, trust in functions of vehicles, because we have to trust the other function of the vehicle if we do a cooperative maneuvering. And this is completely new, and it's also completely new from the OEMs. Let's say trust of another vehicle function. And that's actually something we have not really get into a lot. And there's no real agreement in that on that level. This is why at 5GA we discuss now that we have also to have profiles in the vehicle defining what kind of function is activated based on a message, because if this is not standardized, why should the other OEM trust the other OEM that it's done in the right way? So defining profiles in the vehicle, not only for sending, but also on the receiving side, is something which will come up when we really discuss now trust in functions of other vehicles.
okay, thanks. With this, I think that we are at the top of the hour, or at the end of our hour. I hope it was informative. I thought it was a good exchange, and I really appreciate the questions and answers. And so if you have any further interest, you can come to me or and then interact also by email if you wish. So thank you very much.
Thank you very much.
Thank you.